Let's talk about hacking Android, which of course is the most common, most prevalent type of phone there is. So the Android OS is a mobile operating system. It's based on Linux. It was developed by Google, but there is a large community of application developers, third-party developers, there are thousands and thousands of them, that put apps in Google Play. Most of your apps are written in Java, and they're packaged as APKs. That stands for Android Package. Users can install the apps from Google Play or any place else. When it's installed any place else, we call it sideloading, especially when we are getting it from email or non-website places. The framework for the application allows for component reuse and replacement. This is what makes it so easy for the app dev community, because I could reuse somebody's library or code to do this and do that and that, and all I have to do is code one little bit. I don't have to reinvent the wheel. When you run apps in Android, they run as Java virtual machines, and they run as Dalvik Java virtual machines. The Dalvik VM is a type of Java VM that is optimized specifically for mobile devices. They use an open source WebKit engine for an integrated browser. All data is stored in a little tiny SQLite database. It is a SQL database that, by the way, is susceptible to SQL injection. There is media support for still images, audio, video, all kinds of formats. It is, of course, susceptible to compromise, just like laptops and desktops, and it has additional risks, which we've already discussed. It's particularly susceptible to malicious attachments because users can sideload apps. You don't need to memorize this, but this shows the Android OS architecture. You've got the Linux kernel down here, and we can zoom in. So we can see the Linux kernel includes driver, and remember, a driver is just a small set of instructions that tells the hardware how to use, the operating system, how to use a hardware component. There is a driver for the display, for Wi-Fi, for audio, for inter-process communications, for Bluetooth, camera. There's something that manages power, something that manages processes, manages memory and flash memory, and memory like RAM as opposed to storage like flash drives. So that's the core part. The Linux kernel is made up of all of these drivers or management processes. Then on top of that, you have these reusable libraries, things that as an Android developer I don't have to recreate, I just use them. The SQLite database, WebKit, OpenGL, talking to different kinds of media, talking to the Surface, basically the touch screen, Type, SSL, SGL, libc, core libraries, and the Dalvik virtual machine. You don't need to memorize these, but you need to realize that Android has a lot of moving parts. Down at the kernel, look, opportunity for rootkits, huh? And at common libraries, opportunity for malicious DLLs, and well, I don't think they're called DLLs, but for malicious blocks of code. And then for the user apps, there are different services like managing activities, location, your window, your notifications, your views, your telephony, your content, your resources, and then the apps themselves. Some come with Android, some you download from Google Play or elsewhere. So this is the Android OS architecture. Like I said, Android and iOS uses a concept called sandboxing. The apps are separated from the OS and each other. Each app runs as a Dalvik Java virtual machine. So you can see here's the Linux kernel. And within the Linux kernel, within the file system is a pathway, data something something app 1, data something something app 2. And so we've got app 1 and app 2, each running in its own Dalvik VM, and they have their own little process ID. And then you've got a Dalvik VM just for the system, which is in a more secure area. Developing Android apps, totally not part of this class, but what you have to realize is that there are classes and there's whole communities to help you develop your own apps here. And you can see that we can create an app, including malicious apps, including taking nice apps and repackaging them with malicious content. And you can use, I mean, most people use the Android developer tools, which is sort of a variant of Eclipse. So we can, or it's actually a sort of an add-on thing with all sorts of other functionality. So we can create our little app here, and we can send it over to the user. So it is not that much of a stretch to start creating malicious apps, because there are whole tool sets and whole developer communities and hacking communities that'll help you figure out how to do it. So here are some common Android vulnerabilities. Starting with physical theft. I mean, Android phones are easy to steal or lose. They very often have no passwords. Many users do not enable any kind of password, or the password is very weak. Lack of data encryption. Many apps, including those that use the SQLite database, which is where you store all of your contacts and things, they store data in clear text. The ability to sideload apps from any location, including unsigned apps from any source, even if the device is not rooted. It doesn't have to be rooted. We just say, yeah, I want to do it. Or you root the device, meaning that you basically have root level privilege. It takes off some security features. And some people want that so they have more control over their phones. Unfortunately, that's like walking around with a loaded gun. It is easier to compromise the phone. The little SQLite database, like every SQL database, is at risk of SQL injection. You could have unauthorized access or excessive permissions by apps. Many apps will request more permissions than they actually need, or they don't request permissions at all to use things like contacts, microphones, cameras, location. You will lose, or you could potentially have data leakage when you're syncing to the cloud. So security vulnerabilities in the cloud-based services could expose your device to attack, especially if we use the same password on multiple websites. Someone figures out your password on whatever website, then they go, I wonder if it works in the Android cloud, in the Google cloud. Oh, it does. Great. Lots of folks don't install antivirus or anti-malware on their devices. These are computers, folks. They need endpoint protection. So most users do not install endpoint protection, and that's like comprehensive firewall, antivirus, anti-malware. Most people don't do that, which of course leads to virus infections, unsafe surfing, malicious downloads, smishing, and the like. Most people don't update or patch, and I can tell you this. Here's a common thing that Android users do. We allowed an update to come down, now the thing performs terribly. So we take the update off, including the security protections that it brought us. I mean, I've certainly done that. When I said, man, this thing runs horribly. And the advice is, well, roll back the patch. There are 4 common vulnerabilities that affect the Qualcomm chipsets. Now that's about almost 1 billion Android devices. Any of the 4 could escalate privilege and grant an attacker root access. These are the so-called quadrooter vulnerabilities. You can look this up, look it up by its CVE number here. There's another one, the Certificate M-Reset flaw. This is a flaw in mobile remote support tools, actually remote support tools, sorry. It allows an attacker to install a malicious app and gain control of the device. It affects versions up to Lollipop. No CVE number. There's the stage fright MMS flaw. This is considered probably the most serious Android flaw to date. It allows an attacker to send a malicious video message that will be processed by the native media player without the user even knowing. So it's not like necessarily that the video pops up, but it's going to start playing this video message in the background. You don't even see anything, which includes some kind of malicious code. It permits escalation of privilege and remote arbitrary code execution. It affects versions up to 5.1. Here's the CVE, look it up. You could have a hijacking of the Android installer. We could replace legitimate APKs with malicious ones. It affects older devices up to version 4.1 Jelly Bean, no CVE. There's the Android Fake ID flaw. It allows a malicious app to hijack the trusted status of a legitimate app by forging its digital signature, thus escaping sandboxing. Works up to Jelly Bean 4.3. There's towel root, a kernel level flaw that allows a user to or attacker to quickly root older devices up to KitKat 4.4. There's the Janus vulnerability. You could add malicious code in the form of a DEX file to an APK without changing the signature. So we can append malicious code and it still maintains its signature of authenticity. And there are cross-platform protocol vulnerabilities. Android is a variant of Linux. It is susceptible to the exploits that affect common protocols or features like poodle, crack, dirty cow, things that are not just Android specific. So that's what we need to know about Android vulnerabilities.